Hi guys, hope all of us are doing great. My name is Ernest. I'd like to welcome us to Ernest's Sciences and Mathematics TV channel. In our channel, we deal with the different aspects of mathematics, physics, chemistry, and some topics in biology. And today we are going to look at the role of the nucleus in this specific concept that we refer to as radioactivity. Now, in some of our videos, we have come across this specific concept and we have mentioned a few areas which basically deals with the concept of radioactivity insofar as application is concerned. Now, of course, concerning this other aspect of the nucleus, we have already looked at different models which were advanced over time from the time of Democritus and different ways in which you are going to describe various aspects of the atom, especially the subatomic particles where this aspect of the nucleus false. Now, in today's specific discussion, we're going to try and create a link between characteristics of the nucleus and the concept of radioactivity, or in some way how this specific part of an atom creates or rather plays a role in facilitating this particular process of radioactivity. And in this particular sense, we're going to have a slight recap of what we had learned in different models of atomic structure. And this is going to create for us a basis of understanding basically the relationship that exists between these two specific concepts. Now, from the time of Democritus, there were various advances that were made in trying to describe the structure and fundamental parts of an atom, whereby we see that the introduction, or rather the contribution of two specific scientists, that is Sir Joseph John Thomson, whom we particularly refer to as J.J. Thomson, of course, and the other one was Ernest Rutherford. Now, the work of this scientist, of course, contributed to earlier works that had been done in trying to describe an atom, and they came up with a specific model which forms a basis for the present understanding of an atom. So therefore, I'm going to mention the correlation between these two specific contributions, which is going to assist us, of course, appreciate the role of the nucleus in this specific process of radioactivity. So therefore, if we try to look at the Ernest Rutherford model of an atom, it consisted of this particular center that we refer to as the nucleus. And this nucleus, as described by Ernest Rutherford, consists of this outer space that contained what we call electrons. So in any case, if I try to describe an element like hydrogen, therefore this will consist of the nucleus, which is consisting of a proton and a neutron in this specific center. So I'm going to represent them as particles indicated as such. So it's an electron that is revolving around this nucleus. And in this particular case, we're going to see that there are specific characteristics that we had used to describe this specific center. And we say that the nucleus basically consists of what we refer to as a proton and a neutron for an hydrogen atom, respectively. So these are referred to as subatomic particles together with an electron. But basically, in this particular sense, for the nucleus that consists of a proton and a neutron, the two are referred to as nucleons, or a nucleon for a proton or a neutron interchangeably. So in any case, if I refer to a particle as a nucleon, it can either refer to as a neutron or a proton, and basically this refers to a particle which is contained in the nucleus. Now, in this specific sense, there were some experiments which have been conducted in trying to figure out what are some of the characteristics of these subatomic particles, and one of them is trying to measure their characteristics insofar as charge and mass is concerned. So if we try to look at the concept of charge, and therefore if I'm going to illustrate P for the proton, N for the neutron, and E for the electron, we're going to see that these subatomic particles are going to display various characteristics. And among them, we're going to consider the aspect of charge, whereby we're going to see that for a proton, it's a positively charged particle. So we're going to have the aspect of charge at this specific point. And for a proton, this is a positively charged particle that is found in an atom. For the neutron, this consists of a zero, no charge. So therefore, for the last one, this is an electron that is going to be negatively charged. Now, in this particular sense, of course, we can be able to look at their specific masses. And if we try to do a comparison, of course, they have a very small mass in comparison with the, of course, other particles that we normally come across, especially in classical physics. But I'm going just to mention some figures here, and we will try to do a comparison and see which are some of these, the aspect, or rather the quantity of the mass of these subatomic particles. Now, for a proton, we're going to see that it consists of a mass of that order of magnitude at negative 27 given as such, 1.6 times 10 negative 27 as such. And then for the neutron, we're going to see that it also consists of a mass that is relatively similar to the proton. And then this is negative 27 kilograms. So basically, in order of magnitude, they particularly consist of the same mass. I'm not so specific on the figures, but we can just check on those. Those are just constants which have been established. So in this particular case, for the electron, it's going to consist of a mass of 9.110 negative 31 kilograms. So if you try to compare in order of magnitude for these three, this one can be given a mass of ratio for a proton. Let me just do away with this. So if you consider this aspect of mass and try to consider the proton, neutron, and electron, this is going to consist of a mass, the ratio between a neutron and a proton, if we give them in terms of mass, it's going to be 1. So the ratio between the two. But if you compare the proton, neutron, and electron, then therefore this is going to be in order of 1837, a fraction of this specific mass. So therefore, this implies that an electron has got a very small, or rather relatively a smaller amount of mass compared to these two other subatomic particles. Now, this is going to play a very vital role insofar as some of the experiments that were conducted to try and figure out what are some of their characteristics is concerned, and especially the experiments which were performed by the two scientists that I've mentioned are going to play a vital role in trying to create the relationship between the nucleus and the concept of radioactivity. So therefore, from the work of J.J. Thomson, we're going to see that J.J. Thomson, of course, realized that when an element is bombarded with the alpha particles, now this is going to be, we have already mentioned them in our consolidated discussion on the concept of radioactivities in one of our videos. Now Thomson observed that when alpha particles, when an element is bombarded with alpha particles, some of them are going to be deflected at angles which are going to be greater than 90 degrees. And of course, this was what was observed from J.J. Thomson's experiment. Now, the explanation for this specific kind of behavior was done by Ernest Rutherford, whereby we see that from Rutherford's argument, he tried to explain this particular behavior where some of the particles that were, of course, alpha particles that were, when an element was bombarded by alpha particles, the realization of angles that were greater than 90 degrees, of course, were explained, whereby Ernest Rutherford said that the large scattering was due to the single scattering process, and that this specific angle that was achieved will only be produced by an intense electrical field. So basically, the explanation for this, as per Ernest Rutherford, argued that this will only be achieved through an intense electric field from this specific atom. And therefore, we're going to see that from this specific argument, he further said that this is not only going to be achieved by a positively charged positive charge that resided inside an atom. And therefore, he said that this basically will lead to the conclusion that much of the mass of an atom is located at the center or centrally located. And with this specific center, then he concluded that this specific center is going to be referred to as the nucleus. Now, in this particular case, he argued that there's going to be a number of electrons which are going to be distributed at the outer part of this specific nucleus of an atom. And therefore, we're going to see that these electrons are going to be distributed around this orbit part, which is going to be surrounding this specific nucleus. Now, Ernest Rutherford tried to create a contrast between the planned pudding model that was model of an atom that was advanced by J.J. Thomson by trying to give a present understanding of the atomic structure, which basically are drawn, which shows a nucleus at the center that consists of a proton and neutrons and electrons, which are going to revolve around that specific space. So therefore, from Ernest Rutherford's argument, he said that basically the mass of an atom is particularly going to be concentrated at this particular center. Now that we have said that the ratio between a proton, a neutron, and electron, insofar as mass is concerned, is going to be in that specific order. So therefore, we're going to see that the mass of electrons are going to be negligible in this specific case. So this is going to give us a specific law that is going to be of relevance for us in trying to study the magnitude of the nuclear charge, which basically consists of these specific protons that we have said are positively charged, and therefore we're going to encompass the concept of a nuclear charge, and therefore try to explain this concept of scattering that we have seen that are being investigated by J.J. Thomson and Ernest Rutherford. This basically then therefore is going to explain the concept of charge distribution, and also the relationship between the charge and the scattering that was observed. And of course, we're going to see later that this nuclear charge, or rather the scattering, is going to depend on the square of the nuclear charge. And then basically it's the relationship that is going to be established between intensity and the angle of scattering from these specific experiments that were being investigated by Ernest Rutherford. There was a relationship that was established between the two, whereby we have said that the scattering that was observed beyond 90 degrees resulted in the conclusion of this specific center that is containing much of the mass of an atom. And therefore, we are going to, of course, see that the scattering intensity is going to depend on the square of the nuclear charge that we're going to establish. Perhaps use this particular letter Q, but that is going to be in our other discussion concerning the nucleus. Now, having looked at that specific argument from the two scientists and the figurative illustration of what that refers insofar as atomic structure is concerned, we're going to look at the concept of radioactivity. And we are saying that radioactivity is the spontaneous disintegration of an unstable atomic nucleus to form what we refer to as new nucleus, which basically are going to be referred to as a new particle or daughter particles. And this is going to be accompanied by the release of energy, in terms of electromagnetic radiation that we're going to see later being given as that specific H Planck's constant and the frequency. So this process of radioactivity is going to result in the formation of other new particles that I've mentioned, which are basically the daughter nuclei that we're going to see later in various radioactive decay processes. So we are also going to see that this is going to be accompanied by the release of energy particles and the formation of new daughter cells. Sorry for that, not really cells in particular, but what we refer to as daughter nuclei, which we're going to see later when we're going to represent various radioactive decay processes. So in this case, now I'm trying to create a connection between this specific case, and I've mentioned the concept of radioactivity as spontaneous disintegration of non-stable atomic nuclei. So if you try to look at this specific case, there's a disintegration of a nuclei, which basically implies the concept of a transformation of mass. If you try to look at this, we had said that from Ernest Rutherford and J.J. Thomson's experiments, there was a conclusion from Ernest Rutherford's experiment that much of the mass of an atom is located at the nucleus. Therefore, if you were having a spontaneous disintegration of non-stable nucleus, then therefore this is going to be an effect which is going to be experienced on mass. And therefore this is going to lead us to the conclusion that basically radioactivity is going to be what we refer to as a nucleus process, or a nuclear basically a nuclear process, which is going to basically affect the nucleus insofar as the structure of an atom is concerned. So therefore, if you try to look at our discussion for today, the nucleus and radioactivity, then therefore this is a process that is going to be restricted basically in the nucleus of an atom. And that one therefore creates a relationship that is going to exist between the nucleus and radioactive processes. Now, insofar as the nuclear sizes are concerned, we're going to look at different ways in which we can be able to establish this relationship between the sizes of the nucleus, their density, and how that one is going to have an effect on radioactivity. And of course, we are going to see also that this nucleus is going to have its own specific structure. And when we are going to compare that, of course, we are going to see its also effect on radioactivity. And from its own structure, therefore, we're going to see that there are some short range and, of course, strong forces which are acting on the nucleus, which are going to be, of course, involved in the what we refer to as the fission and fusion processes that we're going to see later as part of the radioactive process, radioactive decay processes. So in this particular case, we're going to also see that specific energy that is being involved, whereby these short range and strong forces are going to be involved in this specific transformation. So that basically creates the relationship between the nucleus and the radioactive processes, to say in a summary. But as we're going to look at other processes later, we're going to see the concept of course, the what we refer to as the mass defect and other areas which are going to be quantitative discussions on these various aspects of radioactivity. So catch us in our next videos where we talk about the different areas in these specific topics, and we're going to look at various radioactive decay processes which are going to complement our videos, whereby they're going to, of course, have an effect or rather contribute heavily to what we have already discussed in this specific video. So that is it for now, guys. Bye. God bless you. Catch us in our next video.